In today's video there is a nice equation that was suggested by viewer. Unfortunately I have no information about this problem. It maybe is a math olympiad or math exam. So anyway, here is the following setup. We have these following equations. We have x plus y plus 2 times z plus t equals a as an integer, and the second equation we have z minus t plus 2 times that is multiplied by the difference of these variables x and y equals b as an integer as well. So our question, we are going to prove there is solutions as an integers for this equation, which are x, y, z and t. Okay, now let's go through this one. So the best way to solve this equation, I'm going through the substitution. Okay, so I'm going to put all this information down here. So let's set x plus y equals m, and x minus y equals n, z plus t equals p, and z minus t equals q. We are going to reduce this equation system to the smallest expression. Okay, so this one, so by adding first equation on the second equation, I get y eliminated. So I will have 2x equals m plus n. So 2x equals m plus n. Okay, for y I'll get 2y. I'm going to subtract second equation from the first equation. I will get x eliminated. I will get 2y equals m minus n. Okay, for the third equation, so I will have 2z equals p plus q. Same thing with t, just this time I'm going to subtract equation number 3 from equation number 4. I will get 2t equals p minus q. I'm going to keep these 4 expressions for later. So we'll have m plus 2, z plus t will be replaced with p plus 2p equals a. The second equation, I will have z minus t, which is q, plus 2 times x minus y, 2 times n equals b. Now my equation system is reduced to the smallest expression. Here is a problem. We have 1, 2, 3, 4 unknown variables. It's more challenging to solve this one with 4 unknown variables. I'm going to name this equation is equation number 1, this one equation number 2. I'm going to multiply equation number 2 by number 2 and sum both equations. Okay, so this one is giving us, I will have 2q plus 2p. So I'm going to put it as a common factor, 2p plus q. For the second term, I will have 4n plus m plus 4n plus m equals a plus 2b. Okay, the reason why I'm doing this one, because I knew p plus q equals 2z. So this one will be replaced with 2z. Okay, also I'm going to work on the second equation to work on p minus q. In order to get p minus q, here is how we have q here. We are going to multiply the second equation in order to get 2q here. Okay, then we put this equation minus this equation to get minus sign between these numbers. Okay, so I will have 2 here as I did before, 2p minus q. We'll have m minus 4n because it was multiplied by minus 2. Okay, this one, the right hand side of this equation become a minus 2b. Okay, like this. Also I knew p minus q equals 2t, so which means I'm going to replace this one with 2t. I'm going to look for m plus n. In order to get m plus n, I'm simply going to multiply the first equation by number 2. Okay, so I'm going to take off number 2 from here and multiply the first equation by number 2. Then sum both equations. I will put 2 is multiplied by m plus n. Okay, this one was multiplied by number 2 here. I will get 4p plus q equals 2a plus b. Okay, very simple. Also I know m plus n equals 2x, so which means this one will be replaced with 2x. I'm going to look for m minus n. In order to get m minus n, I'm simply going to multiply this one by number 2 and subtract this equation, second equation. Okay, 2m minus n plus 4p minus q. This one becomes 2a minus b. The right hand side of this equation becomes 2a minus b. Also I know m minus n equals 2y. Now I'm going to rewrite this expression again. If you take a look carefully, we have extra terms here, n, m, and p and q. So we need to eliminate these variables out of the system. Okay, so how to do that? In order to get rid of these variables, we are going to transfer these variables into x, y, z, and t. Okay, just simply going to add the first equation on the second equation, because we have 4n here, we have minus 4n here. So this is first equation, second equation, third equation, fourth equation. Okay, I will have a new equation here. I will have 4z plus 4t, 4z plus 4t plus 2m. This one becomes a plus a, which is 2a, and 2b will be cancelled out because we have 2b minus 2b, which is 0. Now I get rid of n. I have ended with this first equation. The first equation contains m, also the second equation contains m. This is very simple to get rid of m from here. I'm simply going to put this one minus this one, 1 minus 2. So we'll get 4z minus 4t, 4z minus 4t. M will be cancelled out. I will have 4n minus 4n, which is plus 8n. Okay, so since I put this one minus this one, this means I put this minus this one as well. So which means a will be eliminated. I will get 2b minus 2b, which is 4b. Okay, by putting third equation minus fourth equation, you get 4p eliminated. Okay, so we'll have 4x minus 4y, 4x minus 4y, 4p will be cancelled out. I will have q minus q, which is plus 2q. Here I get 2a eliminated, I get 2b. Lastly, we'll have 4x plus 4y, 4x plus 4y. I will get plus 8p. Q will be eliminated because one is positive, the other one is negative. This one I will get 4 equals 4a. B will be cancelled out. So I have ended with this fourth equation. Okay, now I'm going to get this one at the top and continue solving our equation. Even though with this simplification we still have a problem. We don't get rid of m, n, p and q yet. We need to get to the m plus n. How to get to m plus n? I'm simply going to multiply first equation by number 4 and take number 8 as a multiplier to get m plus n equals 2x. I'm going to multiply the first equation by number 4 here and sum both equations. So I will have 4 is multiplied by 4, which is 16z, 16z plus 4z, which is 20z, 20z. Okay, then 40 it will be multiplied by 4. I will get 16t minus 40, which is 12t. Then next up I will have here 8m plus 8n. I'm going to put 8 as a common factor, is multiplied by m plus n. Okay, equals this one 4 is multiplied by 2a, which is 8a, equals 8a plus 4b. It's very simple. Now this term m plus n, it will be replaced with 2x as I did before. Okay, 2x. I'm going to look for m minus n. In order to get m minus n, I'm going to do the same thing, multiply the first equation by number 4 and subtract the second equation. Okay, so this is the reason I'm doing this one, to replace this term with 2y. So also I have this one equals 2y. I'm going to do the same thing for the third and fourth equation. It will be replaced also with 2z. Okay, for the last equation, I'm going to do the same thing, multiply by number 4 and subtracting equation number 4, which means I will have 16x here minus 4x, which is 12x. But here we have p minus q, so which is minus 2t. Minus 2t. It will be replaced with minus 2t. Also, I will have 8b minus 4a. 8b minus 4a. I'm going to rewrite this one again. Now I'm going to simplify this one and do the same job at a time. Okay, first of all, I'm going to divide both sides by number 4 by putting x as a first variable. Okay, so we'll have here 2 is multiplied by 2, which 4x plus 5z 3t equals 2a plus b. We'll get here 4y plus 3z. We'll get here plus 5t equals 2a minus b. As for the third equation, I will have 20x divided by number 4. I will get 5x minus 3y. I will have 4z. I will get 2b plus a. For the last equation, I will get 12x divided by number 4. I will get 3x. This one is given as minus 5y minus 40 minus 40 equals 2b minus a. Okay, previously I was working on this equation and came up with this linear combination involving 4 variables x, y, z and t. Okay, now I'm going to transfer this one into matrix. Okay, so we'll have 4, y is taking 0 and 0 is taking 5, 3. The second row I will have 5 minus 3, 4, 0, and the third row I will have 3 minus 5, 0, minus 4. The fourth row will have 0, 4, 3, 5 is multiplied by argument vector, which is x, y, z, t equals the argument value, which is 2a plus b, and the second row will have 2b plus a. The third one will have 2b minus a. The fourth one will have 2a minus b. Okay, first row, this one is a second row, this one third row, this one is a fourth row. So I'm going to put this one on this form. So our goal, in order to apply the Gaussian elimination here, I want to be 0 here. Okay, we are going to multiply the first row by number 5 and multiply the second row by number 4 and subtract both rows. Okay, first of all, I'm going to write down all the rows. So I will have the 5 minus 3, 4, 0. So I'm going to change the first row. In order to change the first row, I'm going to apply the Gaussian elimination, which is I'm going to multiply 5r1 minus 4r2 to see what's the values. Okay, first of all, in order to get 0 here, as I said before, multiplying this one by 5 multiplying the second row by number 4 and put this one minus this one. This one is arithmetically is going to be 0 because 5 is multiplied by 4, which is 20, minus 4 is multiplied by 5 is also is 20, which is 0. Okay, I'm moving on to the second one. Second one, 5r1 is 0, is arithmetically 0, minus 4 times is multiplied by this one, which is 12. Okay, so we'll have 12 plus 0, which is 12. So we'll have 12 here. For the third value, we'll have 5 is multiplied by 5. 4 is multiplied by 4 is 16. I will have 25 minus 16, which is 9. So the third value is 9. I'm going to look for the fourth one. Fourth one, 3 is multiplied by 5, which is 15. 15 minus 0, which is 15. Okay. Now, multiplying the first row by 5r1, which is I will have 5 is multiplied by 2a plus b minus 4 times is multiplied by the second row, which is 1, which is this one, 2b plus a. Okay, as I'm changing in this one, I have to change in the same row as well. So now I'm simplifying this expression as 10a minus 4a, which is 6a, which is minus 3b. So I'm going to write this one here, 6a minus 3b. Okay, now I'm going to erase this one and put a new matrix. Okay, so I'm going to use the trick in order to get all this row 0. Okay, so I'm going to multiply the fourth row by number 3 and subtract the first row. Okay, so which means I'm going to put this first row will be transferred as 3r4 minus r1 to see what's giving us. Okay, I will have a new matrix here, everything else not changing except this row. The last row here, I will get 0 minus the first row, which is 0. Okay, then this one becomes 3 is multiplied by 4, which is 12. 12 minus 12 is 0. Okay, I'm applying this one. Okay, so for the third value, I will get 3 is multiplied by 3, which is 9. 9 minus 9 is 0. This one, 3 is multiplied by 5, which is 15. 15 minus 15, which is 0. I'm going to write this one as is it 6a minus 3b. The last one, as I multiplied by number 3, here also I will have 6a. This one will have 6a minus 3b minus the first row, which is minus 6a plus 3b. Okay, so 6a minus 6a is giving us 0. Minus 3b plus 3b is 0. The whole thing is 0, which means this row is 0. So since we get 0 here, I'm going to summarize this one. So for the fourth row is telling us 0x plus 0y plus 0z plus 0t equals 0. What does this mean? This one 0 equals 0, which means we have infinite solutions, which means plug in any value of x corresponding y, z, and t. Okay, so whatever the value of these variables is going to verify this equation. Okay, because we have infinite solution. We will have 0 equals 0 or x equal x. Okay, all that, it means we have infinite solution, because whatever the value of this one is verifying this equation. We have infinite number of solutions. So I have done this problem. If you are interested in watching this one, don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.